exercise 2 related to rate of a reaction, and all the structure questions are there in this exercise. The exercise 1 is having the MCQs. That is also a weekly homework. So the first one, the first question is, when an aqueous sodium thiosulfate is mixed with a dilute hydrochloric acid, a precipitate, a sulfur is formed. So this is a reaction. How we determine the rate of this reaction? Like, rate of this reaction is inversely proportional to time. So what actually happened, that when a sulfur is formed here, sulfur is a solid. So when the sulfur start to form, what will happen? The cross will disappear because the solution will turn cloudy. A light is not able to pass through the solution. That's why the solution will turn cloudy, and we record the time taken by this cross to disappear. If you are using a high concentration of the solution, the cross will disappear faster. And if you use a low concentration solution, then the cross will take longer time to disappear. So this is a method which is used to determine the rate or a speed of reaction by recording a time taken by the cross or a text to disappear. So a student add what the student did. Student add the following volumes of a sodium thiosulfate, hydrochloric acid, and water in the conical flask. As you can see, the time taken for the formation of the precipitate or a formation of a sulfur to make the cross disappear from viewing is recorded. Now, two things are there. If you see that student use the total volume same for all the reactions. How the total volume is same? Like example, when 10 cm cube of a sodium thiosulfate, 10 cm cube of a hydrochloric acid, and 40 cm cube of a water, 40 cm cube of water is used. So what is the total volume of the solution? That is 60. Same way, if 20 cm cube of a thiosulfate is used, 10 cm cube of a hydrochloric acid is used, and 30 cm cube of distilled water is used, what is the total volume of the solution? The total volume of the solution is 60. Now, why student did like this? Why to have the same volume for the two reactions, the two experiment, so that the one which is having a higher volume is that will have a higher concentration in the solution. So why student keep the total volume same? So what is the reason for that? The reason is, if we keep the total volume same, the substance which is having a higher proportion in the mixture, it means that is having a higher concentration. Like you can see here, first we use 10 cm cube of thiosulfate. Then we use 20 cm cube of thiosulfate. So what actually happened, that amount of a thiosulfate is higher or double, it means the concentration of the solution in terms of thiosulfate will also be higher or double. So what is the purpose of using the same volume for all the reaction, like experiment 1, 2, and even for experiment 3 also it should be 60, so that the volume is proportional to concentration, or the solution which is having a greater volume in the mixture or greater proportion in the mixture, that will have the higher number of the particles or higher concentration. That's the reason. This is a common question they ask, like why the volume is constant. So what should be your answer? Your answer should be so that the concentration of a solution directly proportional to its volume. Like, or the substance which is having a greater volume in the mixture should have a high, will have a high concentration. Now, the first part, state the order in which the aqueous sodium thiosulfate, hydrochloric acid, and a distilled water should be mixed. So what order we should mix all of them? Like which one we should add first, which one we should add second? If you see the reaction, if you see the equation, this is a sodium thiosulfate, Na2S2O3, and this one is a hydrochloric acid. So sodium thiosulfate is a reactant. Hydrochloric acid is also a reactant. But why a student is adding a water to the mixture? So that the total volume of a solution should be same for each experiment. Water is not the reactant here. What the reason for adding water is to make the total volume same. Now, what order we should add? Like which one I should add first, which one I should add second, and the third. So what order we should add them? Example, first we add thiosulfate, then we will add water, and then we add hydrochloric acid. Why not hydrochloric acid and a thiosulfate added together? The reason is that because if we add thiosulfate or sodium thiosulfate and hydrochloric acid in the beginning, then the reaction will start. So there will be no use of adding a water. So whenever in this reaction, whenever we select an order, it can be any order, but you cannot add both together in the beginning. So this can also be done like you can add first water, then you can add sodium thiosulfate, then you can add hydrochloric acid. This is also acceptable because first when you add the water, then you add sodium thiosulfate, and when you add the third reactant, then the reaction will start. Order in which you add sodium thiosulfate and hydrochloric acid in the beginning is not acceptable. Why it is not acceptable? Because if you mix sodium thiosulfate and hydrochloric acid, the reaction will start. As the reaction will start, there is no use of adding water in the third part. So any order is acceptable other than the first thiosulfate and hydrochloric acid. So state the order in which the aqueous sodium thiosulfate, hydrochloric acid, and distilled water is added. So example, if you mention, first we'll add sodium thiosulfate. Yes, you can add hydrochloric acid, then water, then sodium thiosulfate. That's also fine. The second you will add water, and the third we will add hydrochloric acid. Is it clear, this part? So it's ordered like I can write hydrochloric acid first, then I can write water, and then sodium thiosulfate. Anyone having a doubt or a question in this? The next part, in experiment 3, student want the thiosulfate to be a double concentration than experiment 2. Complete the volume. Look, student want the double amount of thiosulfate as compared to experiment 2. So what should be the double amount? Like example, if an experiment 2 student was using 40, what is the double of 40? Student used 20 cm cube in experiment 2. So he want a double volume. So what is a double concentration or a double volume? So that will be equals to 40. Hydrochloric acid. So hydrochloric acid amount he did not change, so we won't change. So how much distilled water I should use? What should be the amount of distilled water? So we should use 10. Why 10? Because as I mentioned that we want to keep the total volume of the solution same so that the volume of a volume of a substance in a mixture should be proportional to concentration. So we should use 10 here. Is it clear, this one? So as we change the amount, like for these experiments, like for this experiment, we use 40 cm cube, as I mentioned, double. This we did not change throughout the experiment, and total volume should be 60. That's why we use 10. Now we have to complete this time. How to know? Look, if I increase the concentration, if I use more particles or greater number of the particles in a unit volume, if we increase the concentration, so the rate will also increase. And if the rate will increase, what happened to the time? The time will decrease. Like it will take a shorter time. It will take a shorter time for the reaction to happen. So when I was using 20 cm cube of a thiosulfate, it was taking 28 seconds to disappear. If I double the amount of thiosulfate, I use twice. So how much time it will take? Half. Because if you increase the concentration or the number of the particles in a unit volume, the rate of the reaction will increase. If a rate of a reaction will increase, the time taken by the substance for a reaction to occur, that will decrease. So if the concentration or the amount is double, what happened to the time? The time will be half. So what is half of 28? Half of 28 is 14. Is it clear, this one? Yeah, because the water is not the reactant, water is only changing the concentration of the mixture. Is it clear, the last part? How we work out the time? Say if I change the values here, instead of like double, say we make it 30. So this was 30, this was 10. How much is the volume of water should use? What should be the volume of water? 20. Because the total volume should be 60 in this question. So that's why. Now, if you see a comparison example, if I compare experiment 1 with experiment 3. So how much volume I have used? So like I have used 3 times the volume. So it means the amount of the particle will be 3 times or concentration will be 3 times. If the concentration is 3 times, what happened to the time? It will be divided by 3. So it will be 56. It will be 56 divided by 3, which is 18.66 in that case. But because in the question, the original question, they mentioned we double this amount. So if we double the amount of the reactant, what will happen to the rate? The rate will also be double. And what happened to the time interval? So the reaction will take a shorter time to complete. So it will be divided by 2. That's why it will take 14 seconds. So whenever you increase the concentration or double the concentration, the time taken by the reaction will be half. If you triple the concentration, the time taken by reaction will be 1/3 of the original value. Use the collision theory, explain why increasing the concentration of a thiosulfate would use a collision theory to explain why increasing a concentration of sodium thiosulfate would change the rate of reaction. Look how the marks are distributed because it's of 2 marks. So what is the distribution of the marks? When you check the first one, because if we increase the concentration, there will be more particles in a unit volume. Because higher concentration means greater number of the particle in a unit volume. And if you have greater number of particle in a unit volume, they will have more collision. That's why the reaction will be faster. So if we increase the concentration, what will happen? It will increase the number of the particle in unit volume. And when the number of the particles in a unit volume will increase, what will happen? There will be more collisions. As there are more collisions or more successful collisions, it will have a faster rate. So 1 mark is for mentioning increases the number of the particle in unit volume, and 1 mark is for mentioning more collisions or more successful collisions. The next is a student repeated experiment 1 at a higher temperature. Use a collision theory, explain why rate of a reaction would increase, like why the reaction will be faster. Whenever a question is there, why the rate of a reaction increases as we increase the temperature. So what are the points you will mention? Always like 4 points are there. Sometimes these 4 points have 4 marks. Sometimes these 4 points have 3 marks. So 1 point is when we increase the temperature, the particles have gain more energy or particles will move faster. The second point, when the particle will move faster, there will be more successful collisions will be there between the particles, or greater number of collision or the collision frequency increase. And the third point, greater number of the particles have energy more than activation energy. And as a result, it will have a faster rate. So the points, whenever a question is there related to effect of temperature on the rate, how you write your answer, first point, increase in temperature I'm writing in short temperature as TMP. You can write full. Increase in temperature, increase the kinetic energy and the speed of the particle. Sometimes, some parts like increasing kinetic energy is 1 mark, increasing speed of the particle is 1 mark. Then second thing, what will happen? It will increase the collision frequency. Like more particles collide in a unit time. The third point, there will be greater number of the particles having energy more than activation. So greater proportion of the particles will have energy more than activation energy. So it will have a faster rate. So if you find this question, this should be the answer. Don't try to write stories, just write these points. Increasing temperature, increase the kinetic energy, increases the speed of the particles, more particles collide, greater collision frequency, or a greater number of the particles have energy more than activation energy. Is it clear, this one? Any doubts? The next is the magnesium carbonate react with hydrochloric acid. So you can see the state symbols. Magnesium carbonate is solid, hydrochloric acid is aqueous, give magnesium chloride aqueous, water and carbon dioxide. So whenever a gas is given off, what we can do, there are different ways to measure the rate of reaction. We can collect the volume of a gas given off. And for that purpose, we can use a gas syringe or we can collect this gas over the surface of the water. This is more effective compared to just using a gas syringe, because in this case, when the gas is formed here, so when the reaction happen or occur, the gas is formed, we won't be able to see a colorless gas, but when it passes through the water, it is collected, so we'll see bubbles. Once the bubbles stop forming, it means the reaction has stopped. But in case of a gas syringe, when we are using a gas syringe, that time we have to wait until we find that the volume of a gas in a syringe is not changing. But we are not sure that the reaction has completed. But what is the disadvantage of using this method? Some of the gases are water soluble. Like example, a chlorine, it's a water soluble gas. So when a chlorine is bubbled through water, most of the chlorine will dissolve in water. So for gases which are water soluble, this method is not effective. Then we have to use a gas syringe. Like how to use a gas syringe, we can. So how we use a gas syringe, we just simply connect a gas syringe in this part. So we can connect a gas syringe in this part and that will give us the volume of the gas. But collecting over a water is appropriate in terms of identifying that the reaction completed or no. But again, if a gas is soluble, then it won't be effective. The results we obtained, we are collecting a volume of a gas. As you can see, we collected a volume of a gas for a duration of 500 seconds and we got the total volume of 100. Describe how rate of this reaction changes during a reaction and explain why the rate changes in this way. This is again a common question and it is having a structured answer. Don't try, again, as I mentioned, don't try to write stories. Don't try to write answer. Some of the questions, you will find that the answer is structured. Try to learn that answer. Like this is a question, explain why the rate of a reaction changes. Describe how the rate of this reaction changes and explain why it changes in this way. So first, rate of any reaction, as you can see, rate represented by a slope. So rate of any reaction decreases with time. Rate never until unless we change the temperature, but rate of this reaction decreases with time. So 1 mark when you mention the reaction slow down or rate of a reaction decreases. Then the second thing you have to see in terms of particle, the number of the particle decrease. The number of the particle here we have reactant magnesium carbonate and hydrochloric acid. So number of the reactant particle decreases for both. The third point, you can see a magnesium carbonate is in excess. So when magnesium carbonate is in excess, so it means magnesium carbonate will left behind when the reaction finishes. And hydrochloric acid is completely used up. So why this reaction will stop? This reaction will stop because the hydrochloric acid will be used up completely. Whenever two reactants are there, one of the reactant is a limiting factor and another one is a excess. And in this question, it is already given to you that the magnesium carbonate is in excess. But what if it was not given? So then you can identify if the solid marble chips or solid magnesium carbonate pieces are still left after the reaction, it means that will be in excess. But if you find there is no solid marble chip or magnesium carbonate pieces, in that case, hydrochloric acid will be in excess. So describe how the rate of this reaction changes during a reaction. First thing, what is your first point? The rate of the reaction decreases with time. The second point you'll mention, because the number of the reactant particle decreases and they will have less collision. And the third, like the fourth point, that hydrochloric acid is completely used up, so the reaction will stop. So rate of reaction decrease with time. That is the first point. Okay. What about the second point? So the number of the reactant particles decreases. When the number of the reactant particle decreases, so what will happen? They will have fewer collisions. So smaller rate will be there. And then eventually what will happen? At all the hydrochloric acid is used up. So the reaction stops. Or if you don't want to say hydrochloric acid here, all the limiting reagent, you can say all the limiting reagent. In this case, we have a hydrochloric acid. So all the limiting reagent used up. So how you score the 4 marks for this question? First mark, when you mention the rate of a reaction decreases with time. Second mark, number of the reactant particles decreases. Third point, fewer collisions between them. And at the last, all the limiting reagent or the reagent which is a limiting factor is used up. Is it clear, this one? So this is a structure answer you have to learn. Like, and you will find as we go through this whole exercise, you will find this question is there with different manner, like what happened to the rate of reaction during the time interval or how the reaction proceed. So it will have the same answers. In the experiment was repeated using the same mass, but the powdered magnesium carbonate. And we are using the same volume and the concentration of hydrochloric acid. Like we did not change the limiting factor. What we only did, we use a powdered form instead of the lumps, like a large pieces. And we did not use in the beginning, we used large pieces of magnesium carbonate, but now we are using a powdered form. So whenever we change the surface area, what is the effect of the surface area on the rate of a reaction, the rate of a reaction will increase. But because we did not change the amount, even if we change the amount, it won't affect the amount of product. Why it won't affect the amount of product? Because if we change an excess reagent, the amount of the product does not change. Amount of product only changes if we change the limiting factor. So it will affect the rate. So the question was, what happened to initial rate? Like what happened to the rate of a reaction or the rate of a reaction in the beginning? So the rate of a reaction will increase, or the reaction will be faster. And why it will be faster? Because powdered form will have a large surface area. So it will have more collagens. So initial rate will increase. And what happened? Because the powder will have a large surface area. So there will be more collagens per second or higher collagen frequency. But what happened to the total volume of the gas? Total volume of the gas remain same. Why the total volume of the gas remains same? Because even if we use a reagent which is excess and we increase the amount, the total volume of a gas does not change. So total volume of the gas, it will be same, like, or constant. And what is the reason? Because we use the same number of particles or same amount of the reactant. The next part, a piece of a magnesium ribbon is clean. This experiment was repeated using this clean magnesium ribbon instead of magnesium carbonate. This reaction is exothermic. The rate of a reaction gradually increases over the first 2 minutes. Explain why the rate of a reaction increased. And see the weightage of the marks, like weightage of this question, it's of 5 marks. And when you see the answer, the points are very simple. Like these are the same points which we discussed in the first part. So the reaction is exothermic. First, when a reaction is exothermic, it will release energy. So as a result, when it will release energy, the temperature of the mixture will increase. Because the reactant release energy and the temperature of surrounding is a mixture, the content in the flask. So temperature of the mixture increase. When the temperature increase, the kinetic energy of the particles will increase and the speed of the particles will increase. When the speed of the particle increase, there will be, it will increase the collagen frequency. And there will be a greater number of the particles having energy more than activation. So how the marks are distributed, especially for this question? So the distribution of the marks, the first thing you mention a temperature increase because the reaction is exothermic. So the temperature increase, that will score 1 mark. Particles have more energy, that will score the 2nd mark. When you mention particles have, and particle will move faster, that will score the 3rd mark. Like speed of a particle increase, that is the 3rd mark. There will be more collagens, that is a fourth point, like 4th mark. And greater number of the particles have energy more than activation, that is a 5th point. So that's why I say whenever a question is there relating the effect of temperature on the rate or the speed of a chemical reaction, you will always include these points. Higher temperature, more higher kinetic energy, particles move faster, they will have greater collagen frequency, there will be more number of the particles, or greater number of the particles have energy more than activation. So next question is similar question is there. As you can see, we have hydrochloric acid and excess of marble chips are there. The first one, in question two, we collected the gas over the bottle, but here we are just collecting using a gas syringe. How does the shape of a graph shows the rate of a reaction decreases as the reaction progresses? So the shape of the graph, how it represents the rate of a reaction decreases. The this, because what actually happened, the gradient representing the rate. The gradient or the angle is decreasing. The gradient is decreasing, and why the gradient decreases? Because number of the reactant particles decrease, and as the number of the reactant particle decreases, what happens? There will be fewer collisions. So as there are less or few collisions, that's why the reaction will be slower. Why did the rate decreases as the reaction progress? So this is the answer, like the first part. So what actually happened for this one? So the number of the reactant particle or a limiting factor is decreasing. That's why the rate of the reaction will decrease. Like in the beginning, you will have more particles, more collisions, but as the reaction progresses, the limiting factor particles are decreasing more. As a result, the reaction will be slower. How many seconds did the reaction finish? So how to work out when the reaction finishes? So when the line changes to horizontal, that shows the reaction stops. So at what point it will appear that because if I zoom in, you will find even around 120. So around 120, it is a horizontal line. Like this point, it become horizontal. After this point, it become horizontal. So it become horizontal. What we can say at 120 seconds, the reaction has stopped. Then experiment was repeated using a same mass of a smaller pieces of a marble. Draw on the graph. So if you use a smaller pieces of the marble, the reaction will be faster. So it will be much steeper. So reaction will be faster. It will be much steeper. But the final amount or the final volume should be same. So when we sketch a graph here, so steeper and it will complete quickly in a short time, but the final amount will be same. And you should label as like example, because you make it for B. So you should write that this is for B part. It's important that you not only draw, but you have to label for which part you do this. So whenever a reaction is faster, it will be much steeper. Then the original experiment was repeated using a higher temperature and explained in terms of collision between the particles. And it's again a 5-mark question. So how the marks are distributed here? First mark, when you mention it like increasing a temperature, the particles have more energy. It will take less time. The particle will move faster. There will be more collisions or higher collision frequency, or there will be greater number of the particles have energy more than activation. So this reaction will take less time. The particles have more energy. Particles move faster. Particles have greater collision frequency. Greater number of the particles have energy more than activation. So this was like these are some questions from exercise rate of the reaction, exercise 2.